Our lives are filled with cycles, repeated patterns of events that happen over and over again. These cycles are everywhere, from the changing seasons to the migration of animals. Some cycles are natural, like the rhythms that control when we sleep, while others are things we create, like the patterns in music or how we grow and harvest crops. Cycles aren't just important in our daily lives. They also have a big impact on the weather and climate of our planet. About 100 years ago, a scientist named Milutin Milankovitch came up with a theory. He said that the way the Earth moves around the sun over long periods of time can cause big changes in our climate. These changes might even be the reason why ice ages start and end. Some people strongly deny that we've had a significant effect on the climate change, while others are absolutely certain of our influence. So, where does the truth lie? To know more about the Earth's weather cycles, stay with us till the end of this video. Understanding the Earth's position in the solar system is a fundamental aspect of comprehending the complex interplay of factors that influence our climate. At the heart of this understanding lies the Earth's axial tilt, a characteristic that plays a central role in the seasonal variations experienced across the globe. The Earth's axis is tilted relative to its orbital plane around the Sun, an inclination of approximately 23.5 degrees. This tilt is responsible for the changing angles at which sunlight strikes different parts of the Earth's surface as it orbits the Sun. As a result, different regions experience varying amounts of sunlight throughout the year, leading to the familiar cycle of seasons. Consider Tromsø, a small town in Norway situated at a high latitude. Due to its location and the Earth's tilt, Tromsø experiences extreme seasonal variations. In summer, when the hemisphere is tilted towards the sun, the town witnesses the phenomenon of the midnight sun, where daylight persists for extended periods, sometimes for months without a sunset. Conversely, in winter, when the hemisphere is tilted away from the sun, Tromsø plunges into darkness for an extended period, experiencing the polar night. However, the Earth's tilt is not a static feature. Over long periods of time, it undergoes slight variations known as axial precession. This process involves a gradual wobble in the orientation of the Earth's axis, which can influence the intensity and duration of seasons over thousands of years. These variations in axial tilt contribute to long-term climate variability on geological timescales, shaping the Earth's climate over millennia. Furthermore, the Earth's orbit around the Sun is not a perfect circle, but an ellipse, meaning that its distance from the Sun varies slightly throughout the year. This orbital eccentricity, combined with the axial tilt, contributes to the seasonal differences in solar radiation received by different regions of the Earth. Additionally, the Earth is not isolated in space, but interacts gravitationally with other celestial bodies, particularly massive ones like Jupiter and Saturn. These gravitational interactions, known as perturbations, can influence the Earth's orbit and axial tilt over long timescales. The gravitational pull of Jupiter and Saturn, for example, can cause slight variations in the Earth's orbital parameters, leading to changes in the timing and intensity of seasons over thousands of years. These interactions between Earth and other planets create a complex dance of gravitational forces, shaping the long-term climate patterns on our planet. In summary, understanding the Earth's position in the solar system, including its axial tilt, orbital eccentricity, and gravitational interactions with other celestial bodies, is essential for comprehending the intricate mechanisms driving Earth's climate variability over both short and long timescales. These factors contribute to the rich tapestry of seasonal changes experienced across the globe and play a crucial role in shaping the Earth's climate over geological epochs. These variables stabilize into cycles, first effectively described by Serbian geophysicist Milutin Milankovitch in 1920, known as Milankovitch cycles. One of these cycles is the changing shape of our orbit. Over 100,000 years, Earth's orbit shifts from more circular to more elliptical. When the orbit is circular, our distance from the sun remains fairly consistent, giving us a steady amount of sunlight all year. But when the orbit is elliptical, there are times when we're farther from the sun and colder, and times when we're closer and warmer. Currently, the Earth's orbit is more circular, with the perihelion, closest point to the Sun, around January 3rd and the aphelion, farthest point, around July 4th. This seems to give the Northern Hemisphere more stable seasons, while the Southern Hemisphere experiences more extreme seasons. But don't worry, another cycle balances this out. In the grand tapestry of existence, Earth's cycles weave a rich narrative of continuity and change, of harmony and discord. At the heart of this tapestry lies the celestial waltz, orchestrated by Earth's axial tilt, a dance that spans millennia and shapes the very essence of life on our planet. Like a master conductor guiding an orchestra through a symphony of seasons, Earth's tilt leads the way, pointing towards the steadfast North Star, Polaris, as our planet traverses its cosmic path. This journey through the stars, spanning over 26,000 years, promises a future where the rhythms of nature may unfold in unexpected ways. As Earth's axis tilts towards different stellar guides, the familiar patterns of seasons may shift, offering a glimpse into a world where the Northern Hemisphere basks in the warmth of summer amidst the depths of January, while the Southern Hemisphere embraces the wintry magic of a Christmas landscape adorned in snow. It's a testament to the intricate interplay of cosmic forces, each thread woven into the fabric of life itself. Yet, amidst this cosmic dance, there lies a delicate equilibrium, a tension between stability and upheaval, between predictability and unpredictability. The rhythmic pulse of ocean currents, the symphonic resonance of diverse ecosystems, all echo the cyclical rhythms that imbue our world with a sense of order and continuity. But within these harmonious cadences lie the seeds of chaos, waiting to be unleashed by the extremes of nature's cycles. Humanity, positioned at the nexus of Earth's evolution, finds itself both participant and observer in this cosmic drama. As stewards entrusted with the care of our planet, we are tasked with navigating the complexities of Earth's cycles, embracing the lessons they offer in resilience and adaptation. It's a journey fraught with challenges, yet brimming with potential, a journey towards a future where balance and sustainability reign supreme. In the face of mounting environmental challenges, a collective commitment to stewardship emerges as imperative. By recognizing our interconnectedness with Earth's cycles, we unlock the potential to forge a future where humanity lives in harmony with the rhythms of nature. This journey towards harmony is not without its obstacles, but the destination, a world in harmonious alignment with the cyclical patterns of the cosmos, beckons with a promise of hope and renewal. It's a future where humanity embraces its role as caretaker of the planet, where the rhythms of Earth's cycles are honored and respected, and where the tapestry of life continues to unfold in all its vibrant diversity. Each step forward is a testament to our commitment to stewardship, a commitment to preserve and protect the precious balance of life on our planet for generations to come. I hope now you all got a fair idea on how the weather cycles work. Tell us what you think about this beautiful weather cycle of Earth in the comments section below. Like, share, and subscribe to our channel for more such informative content.